time division multiplexing. FDM used in telephony system. FDM used in telephony system. FDM frequency division multiplexing uses in telephony system. FDM frequency division multiplexing. Frequency division multiplexing. Frequency division multiplexing used in hierarchical structure. Used in hierarchical structure. Basically, the many telephone network uses many telephone network use FDM, in which telephony channels are allocated at different portions of frequency portion of the spectrum. For integrating lower level FDM signals, frequency division multiplexing signals, each of these various multiplexing rates in the FDM hierarchy are used. For integrating lower level of frequency division multiplexing signals, each of the various multiplexer rates in the frequency division multiplexing hierarchical structures are used. And in standard telephony voice bands use standard telephony voice band signal signals and stacked on high frequency carrier by single sideband amplitude modulation. After modulated any message signal, we had upper sideband and lower sideband, but we have to transmit it in single sideband for purpose of requiring the low power signals. This is the most bandwidth efficient scheme possible, and this is the most utilization of the bandwidth efficiently scheme for possible. Analog carrier systems uses FDM technology. Analog carrier system uses frequency division multiplexing technologies. One of these hierarchical systems used by telephone companies is made up of the hierarchical structure. It is a hierarchical structure means stage by stage different levels are used to increasing the number of telephone signals, number of voice signals. For carrier system uses FDM technology. One of the hierarchical system used by telephony companies is made up of groups. First one is equal to group, second one is super group, and third one is master group, and fourth one is jumbo groups. And this is the basic structure in this analog hierarchical structures were used for the standard voice signals. Standard voice signal 12 voice signals are multiplexed onto the higher bandwidth line to create a group. 12 voice channels are multiplexed on a higher bandwidth line to create the group. Yellow socket galan, old galan gal. the basically 12 voice channels are multiplexed onto a higher bandwidth line to create the groups. And we have to move to the next slide. We have to go to the next slides. Here going to the next slide, we have to go to the next slide. Here basically at frequency division multiplexing at 12 and 16 and 20 kilohertz, the analog voice signals are pre-grouped into this and heterodynated on carrier signal. The resulting upper side bands of four schemes, upper side bands of our four groups and three groups are to be heterodynated to form check pre-group are then heterodyned to form a 12 channel groups on carrier at 84, 96, 108, 120 kilohertz. And you can use basically at a time 12 voice signals, and can use it by 84 voice signals, and you can use 96 voice signals, and also used in 108 voice signals and 120 kilohertz voice signal. And this process can continue till available bandwidth. This process can continue until available bandwidth on the coaxial cable or microwave links is exhausted. And also is a microwave link are exhausted. Then in North American systems are used. Three groups are divided into 12 channels, and next super groups are divided into 5 groups, and master group is divided into 10 groups. 10 groups is divided into master groups. 10 groups is divided into master groups. And jumbo group is divided into 6 master groups. 6 master groups is called as a jumbo group, and 10 super groups is called as master groups, and 5 groups are called as super groups, and 12 voice channel is called as a group. In this way, we have to utilizing the North American states are used for this technology to use for these various groups to allocating the channels in the North American system. Next, we have to go to this next slides. We have to move the next slides. Is in European countries are used. Next, European countries are used for this. In the European countries, CCITT systems are there are 12 channel pre-groups, 12 channels pre-groups, and 5 groups for super groups, 5 groups for super groups, and 5 super groups for master groups, and 3 master groups for super master groups. These all other groups are divided into various in European countries. European states are established that countries to using the PSTN technology and sharing the signals by European countries of CCITT system, 12 channels for groups, and 5 groups for super groups, and master groups for master groups for super groups, and three master groups are called super master groups, and this is the way we have to utilize in the various groups. And then we have to go to the next slides. Here basically do these various groups and various levels are multiplexed post navigation system. This is used for in navigation system. Navigation system is basic groups and first level, second level, and third level. This is the post navigation system. This is used for navigation system first level. First levels are allocating the frequency group of mixing. Group of mixing is SSB 64 XSB. Each bandwidth allocated 4 kHz. Then we have to add a 12 voice signal, very high frequency signal. 12 very high frequency for 12 voice frequencies. The first level of the FDM is equal to SSB 64 kHz and added to the single sideband 64 and single sideband 68, single sideband 72, single sideband single sideband is 76, single sideband single sideband single sideband single sideband single sideband single sideband to added the each signal is added 4 kHz, each 4 kHz for post navigation technology. This is the navigation technologies for using navigation for adding of this navigation of for navigation system and for navigation system is allocating navigation system used for navigation system to allocating the navigation system is allocation of navigation system is allocating of the noise signal
काम कर रही हो काय बळगी झाले बळगी पुरा आजची फली पोगा आहे नाही म्हणजे ये रे ना बळगी काम
allocation of this allocation of this allocation of navigation and SSB single sideband 64, single sideband 68, group of mixing, and a single sideband of 48, single sideband single sideband of 64 SSB and added to the 4 kHz 68, and single sideband added to 4 kHz 72, and 4 kHz is 76 and added to the 4 kHz 80, and added to the single sideband added again 4 kHz is equal to increasing the frequency allocation 84 plus 84 is added to the bandwidth of the 4 kHz 88, and 88 kHz added to the 4 kHz is equal to 92. 92 is added to the 4 kHz of 96. 96 added to the 4 kHz of 100. 100 is added of 4 kHz is equal to 104. 4 kHz added to the 108. This is the first level of the FDM2 multiplex dual voice signals. After the adding is summer will be allocated with the summing of the allocation of the signals. Here 3 levels of FDM is the hierarchical structure, and then goes to this second level is the group of 5 groups added to the basically the construction is 12 voice signal, basically 12 voice signal, and then added to the 12 levels of signal into 12 level of voice signals is multiplex and added to the summing, and then that can be output of this each summer is multiplexed into 5 groups. That 5 groups is added to the single sideband 5 groups is mixing of the 5 groups, mixing of the 5 groups is mixing of the 5 groups, mixing of the 5 groups is 5 groups single sideband is 420 multiplexed with the carrier is 5 groups. Total bandwidth is 40, each bandwidth 4 into 12 is equal to total bandwidth is equal to 48 kHz. The output is equal to 48 kHz is the bandwidth, and total the 48 kHz. 48 kHz of bandwidth. 48 kHz of the bandwidth, and 5 groups. Output is total bandwidth is equal to 48 kHz. 48 is the bandwidth is 48 kHz is the bandwidth. KHz is the bandwidth. 48 kHz is the bandwidth. 48 first level and second level and third level. First level, second level and third level. First level and second level, third level. Adding the signal. First level, second level and third level. एक काम करो third level. Third level. Third level. Add it. Increasing the signal levels one by one. Increasing the navigation. First level, second level, and third level. To add the bandwidth. To add the bandwidth of this signal. Added with the bandwidth of the signal. Bandwidth of the signal. Signal is added to the 4 kHz bandwidth. 4 kHz of the bandwidth added to the signal. Added to the signal is added to the signal. Added to the signal. the signal added to the bandwidth of the signal. Bandwidth of the signal added to the bandwidth, first level group, second level group, third level group, fourth group, sixth group, seventh group, added to this various levels, various stages. Various levels and various levels, various stages. Now is first level group, second level group and third level group, jumbo group. Jumbo level group. Jumbo level group. Various stages of this various levels, and second level added to the 5 groups and summing those and multiplex them, and that will be 5 into 10 groups, summing of 10 groups and 48. Then we had multiplex 5. Then we have 10 super groups and 240 kHz bandwidth, and 48 into 5 is the 420. In navigation system, we are using the navigation system. 5 into stages, 5 into super group and master group, and 10 to 40 kilohertz, and that is the super group is mixing of super group, mixing of super groups, and mixing of super group, and total bandwidth 240 kilohertz, 240 kilohertz bandwidth, and totally means third level is master group. Then we are increasing the to 420, 468, 516, 546. Basic groups. Basically 5 groups. Super group is mixing, and 10 super groups. Total bandwidth 240 kilohertz, and master group is third level is SSB, and 10 into total bandwidth. Again, master group is multiplex is the previous output. We have to get the master group. We have to mixing the multiplexing at third level. The bandwidth is each one having the 4 kilohertz, and then we have to summing of this master group Master group is 2.52 megahertz. 5.2 megahertz. Then we have to go to the next level. Next slides. Multiplexing hierarchical structure in FDM, frequency division multiplexing, and FDM hierarchical different levels of the multiplexer. There are shown combined manner and various level as shown in figure. This is the FDM. Here 12 voice signals and each 12 voice signal 4 kHz bandwidth and multiplex. Then we have to get the output is called as the supergroup. 12 voice signal is 12 into 4 is equal to total bandwidth of the 48 kHz. That group is multiplexed with the 5 into 12 voice channel. We have to get the output of the second level of the FDM. Frequency division multiplexing is 60 channels, and total bandwidth is equal to 48 kHz. 48 into 5 groups, so that is equal to 240 kHz. 240 kHz, that is the output. We have to get the super group. That super group is 60 channels is equal to 240 kHz is the super group. That output of the 240 kHz super groups is multiplex with the 6 super groups. That we have the output of the super group into multiplex with the 6 super groups, that is equal to previously 60 into 6, 600 channels. 10 groups we had multiplex here. Super groups 10 into 60 means 100 channels, and a bandwidth is equal to 2.52 megahertz. A bandwidth is equal to 2.52 megahertz. The output is called as the master group. That is the master group is equal to total channel is equal to 600 channels, and bandwidth is equal to 2.52 megahertz bandwidth. Then master group is again multiplex with the 6 master groups, and 6 into 6 total is equal to multiplex into 600 into 6, 3600 channels. That output is called as the jumbo group. Jumbo group is 6 into 300, 6 into 6, 3600 channels, and the bandwidth, the total bandwidth is equal to 16.984 megahertz. This is the way we have to increasing the hierarchical structure of the hierarchical structure of the hierarchical structure of this hierarchical structure of the frequency division multiplexing. Frequency division multiplexing. Frequency division multiplexing. Frequency division multiplexing. Hierarchical structure of the frequency division multiplexing. And a group basic groups as equal to 12 voice signals, and basic group basic group and basic group and 12 voice signal is equal to 48 kilohertz, and 60 channel super groups and 10 groups is equal to 60 into 240 kilohertz, and 10 super groups into master group 600, and total bandwidth is equal to 2.52 megahertz, and 360, and the output of this jumbo group is equal to 600 into 6, that is equal to 3600 channels. Total bandwidth is multiplied with the previous 2.54 megahertz, that is 16.984 megahertz. This is the hierarchical structure of this. The level 1 denotes the basic group in which 12 voice channels are multiplexed together. multiplex together. And second level is equal to supergroup. Second level is equal to supergroup is in which 5 basic groups are multiplexed together. As each basic group has 12 voice channels, so in level 2 we have 60 voice channel. Level 2 60 voice channel. Next slides we have to go to the level 3. Third level 3 is the master group. Level 3 is the master group in which 10 super groups are mixed together. 10 master groups. Level 3 is the master group in which 10 super groups are mixed together and have up to 600 voice channels. Voice channels are increased according to the multiplexes are increases. Bandwidth also increases. At fourth level, you get the fourth level is denoted as a jumbo group. How to get the jumbo group in the fourth level? Fourth level is the denoted as a jumbo group. Jumbo group is which has 6 multiplexed 6 users are multiplexed in the master groups, and then we have to get this fourth level as the total master groups. Then what is the need for basic group? What is the need for basic group is basic group is basic group is basic group is basic group basic group is basic group is a jumbo group has a 16 multiplexed master groups. What is the basic group? A group that has 12 multiplexed voice channels. These voice channels modulated the carrier signal in the frequency range. That frequency range is 60 kHz to 108 kHz. 60 kHz 60 kHz నుంచి 108 kHz and space rate of 4 kHz for each other, means we have to use the guard band. Then totally we have to get 3600 voice channels. 3600 voice channel. 3600 voice channel. Then what is the basic group here? A group that has basic group has to multiplexed voice signal voice channel. This voice channel modulate the carrier signal in the frequency from 60 kHz to 108 kHz. Then we have to go to the next slide. Here, frequency to plan for basic group of FDM as shown in basic diagram here. Total each first channel occupy the frequency. Total first channel, second channel, third channel, fourth channel, fifth channel, sixth channel, seventh channel, eighth channel, ninth channel, 10th channel, 11th channel, 12th channel. Each channel occupy the 4 kHz is the bandwidth. Each channel occupy the 4 kHz is the bandwidth. 4 kilohertz is the bandwidth. The 1 2 3 4 5 6 12 into each bandwidth is 4. 4 into 12 is equal to 48 kilohertz. Therefore, each channel occupies the channel space is 60 to 64 kilohertz and 64 to 68 kilohertz and 68 to 72 kilohertz, 72 to 76 kilohertz. Ninth channel occupy the channel and that channel in between the 72 76 is the bandwidth of ninth channel. Eighth channel can use the channel width is 76 and 80, that is the frequency range. The frequency range used for the eighth channel. And seventh channel used in the frequency range is 80 to 60 hertz, and the range is between the 60 to that is 76 to 76. Then we have to increase this 80 to 84 in between the range. Then we have to use in this way we have to increase the total channel is 66 to 108 frequency range. Each channel number is allocating the channel number, the frequency range utilize the carrier frequencies, and in this way we have to planning this frequency division multiplexing. Then we have to go to the next slide of this next slide for this FDM used in telephony system. He uses the single sideband modulation technique so that we can save the bandwidth. The best application we have to television and radio system where multiple signals are transmitted over a single channel with different frequency slots. Then we have to go to the advantages of next slide. The advantages of this frequency division multiplexing in FDM. It is a synchronization free techniques, as we do not need a synchronization between transmitter and receiver. Synchronization free techniques, we do not need a synchronization between the transmitter and receiver. It facilitates the transmission of the large number of signals simultaneously. It facilitates the transmission of the large number of signals simultaneously. The frequency division multiplexing FDM used in demodulation is easy to demodulation of frequency division multiplex. These all are the advantages of this telephony system. Next slide we have to use the next slide the advantages to move this next slide, and we have to use this. After this we have to get advantages no need for signal. It is a facility the transmission of large number of signals simultaneously and use demode. The next slide is the disadvantages of channel bandwidth is required the large and there is a cost of crosstalk between band disadvantages of Disadvantages of telephony system using FPL. Channel bandwidth is required is large, and it can result in crosstalk as several signals are transmitted during the same time interval. It can result in crosstalk as several signals are transmitted during the same time interval. During the same time interval, it can cause intermodulation distortion. It can cause intermodulation distortion. Channel bandwidth is required. The large it can result crosstalk of the several signals are transmitted during the same time interval. It causes the intermodulation distortion, and inter uh, these are the disadvantages of channel bandwidth is large. It can result in the crosstalk as several signals are transmitted during the same time interval, cause intermodulation. In this way, this is the hierarchical structure of this hierarchical structure of this hierarchical structure of this frequency division multiplexing. Structure of the frequency division multiplexing. In this way, we have modulated these advantages, disadvantages over this frequency division multiplex using a hierarchical structure.